All right, in this video we're going to talk about one-to-one functions and the importance of needing why a function needs to be one-to-one in order to have an inverse. So first of all, what is a one-to-one function? Well, this is an example of a function that this is not one-to-one. And the reason why is one-to-one says if you're given any two different x values, their y values must also be different. So given x1 not equal to x2, then f of x1 can't be equal to f of x2. So in other words, they need different y values. To determine if a function is one-to-one, you can apply the horizontal line test. But this is not one-to-one because when I take two different x values and plug it into my function, we get the same y value. All right, so that's why that's not one-to-one. Why is it important that a function is one-to-one to have an inverse? Well, let's look at this example where x1 and x2 have the same y value. All right, so if I take x1 and plug it into my function, out comes f of x1. Out comes this y value right here. So when I plug this y value in to here, the question is, what x value does it go back to? It could go back to x2 because that has the same y value, or it could go back to x1. It's ambiguous. We don't know. And that's the problem with the function not being one-to-one, is when I plug it in, if there's two x values that have the same y value, when I plug the y value into the inverse, it doesn't know which x value to go back to. That's the problem with a function that's not one-to-one and trying to talk about its inverse.